Good afternoon and good morning, everyone. Welcome to the Swiss Korean Science Club, meeting CIS, EPFL, and ICE DGIST. I'm Alessandra Picella, the head of the Science and Technology Office at the Embassy of Switzerland in Seoul. We are part of SwissNext, the knowledge hub aimed at connecting Switzerland and the rest of the world in education, research, and innovation. Our monthly Swiss Korean Science Club highlights and promotes cooperation between the two countries in diverse fields of studies. The digital version of Science Club, which we started last year along with the COVID outbreak, is giving us new opportunities to be connected, at least virtually, with our partners in Switzerland and many other places around the world. So it's our pleasure to welcome you here. Today's Science Club will start soon with 3 speakers from the Center for Intelligent System at EPFL and Department of Information and Communication Engineering at DGIST. We gladly introduce the directors and professors from the 2 institutions from Switzerland and South Korea to introduce the organizations and share exemplary research supported by the institutions. Our first speaker is Jan Kerschgens, Executive Director of the EPFL Center for Intelligent System. Receiving a PhD degree in bioengineering from EPFL in 2009 and trainings in project management with an executive MBA from the Haute École de Commerce de Lausanne, Ian has worked in management positions related to research and development, innovation, and technology transfer within the industry. He will guide us through the main scope and activity of CIS in EPFL. Our next speaker is Dr. Anastasia Bolotnikova, a postdoctoral researcher at Biorobotics Laboratory at EPFL. She leads the collaborative initiative of the CIS on assistive distributed robotics as well. Her main research interests lie in robot control, motion planning, human-robot interaction, and the application of robotics technologies with regards to the assistance for people with special needs. Last but not least, our third speaker is Professor Kyung-Wan Jin, Assistant Professor of the Department of Information and Communication Engineering at DGIST. After receiving a PhD degree in bio and brain engineering from KAIST, he served as postdoctoral scholar at EPFL and as a staff engineer at Samsung Research. His research interests include image processing with deep neuronal networks, inverse problems, computational photography, and multidimensional signal processing. I truly hope the Swiss Korean Science Club will offer every one of you a great time to learn about the research institutions in Switzerland and in Korea. And also, I wish our Science Club new opportunities for potential exchanges and joint cooperation between the 2 countries in the near future for the participant, also in the next bilateral joint calls. Thanks very much. And now, Ian, the floor is yours for the first presentation.
Thank you very much for your kind introduction, Alessandra, and the invitation to present you the EPFL Center for Intelligent Systems. Just a second. I'll pull up my slides. Welcome to this brief introduction to the EPFL Center for Intelligent Systems. My name is Jan Kerschgens. I'm serving as Executive Director of the Center. Professor Bia van der Geins serves as the Academic Director of the Center. The center itself is based at EPFL, and it is the only structure at EPFL that is constituted by all 5 faculties of our institution. This is the School of Architecture, the School of Computer and Communication Sciences, the School of Basic Sciences, the School of Engineering, and the School of Life Sciences. The mandate that had been given to us from the directorate of EPFL was to create a common platform where all researchers from all different disciplines working on artificial intelligence, computer vision, machine learning, robotics, but also the applications of, for example, machine learning and basic sciences can meet, discuss, and exchange. Here to the right, I've put us a small sneak preview of the types of project that we've launched since the inception of the center by beginning of 2020. The first one is AI for medicine. The second one is intelligent assistive robotics. Dr. Bolotnikova is going to present us more details after my brief introduction. The third one is on Edge AI, and the fourth one is on digital twin. Some more in preparation. Maybe just some words of the governance. At EPFL, we have a central structure where all centers are attached. This is led by Professor Foncoberta Moral. We have a highly engaged board, which is constituted by the deans of the 5 faculties. I mentioned Pierre and myself, and of course, there's a great support provided by an entire management team for all matters related to the center. Here we see the scientific committee. You can imagine that we get 3 to 4 delegates from each faculty, which dedicate their time to actually think about how the center should evolve, what types of project we should do, what types of project we could propose to initiate. You see again the acronyms that stand for the different faculties, and you see the names of the professors which are engaging with the center. The mission of CS, very briefly, is to advance the state of the art in research in intelligent systems at EPFL. So we are an EPFL research center, but we also would like to enhance collaborations not only within EPFL, but also with partners, be this industrial partners, be this university partners. We strive to further create and strengthen the community at EPFL through the initiation of ambitious collaborative projects to actually construct these intelligent systems. So systems you get to once you bring different components like machine learning, computer vision, and robotics, for example, together. Last but not least, we also have the mandate to act as a point of contact for industry. Maybe just very briefly before I let the stage to Dr. Bolotnikova, we have launched 3 key programs in 2020 that I would just like to briefly describe. The first one is the CIS Get to Know Your Neighbor seminar series. This is an internal seminar series which you have access to through our website once the recording has been finalized. Then we have the CIS Colloquia, where we actually invite renowned speakers from other universities to present their areas of research. And last but not least, we have put in place an instrument to actually promote the creation of new integrated research streams within our institution. So just briefly, these seminars will allow you, if you go to a website, to actually see what the different labs are working. You will find more than 30 speakers so far, and they will explain to a more general, wider audience, because these are campus-wide seminars, not specific for one faculty, what they are working on and the types of interests and problems they have. With this, we strive to promote internal exchange, but by putting them online, we also would like to encourage outside stakeholders to inform themselves about research going on at EPFL. The CIS Colloquia, which we launched in June 2020, we put in place to actually foster the dialogue around the state of the art of intelligent systems, promote visibility not only of our researchers, but also the domains themselves, and to strengthen relations with international institutions. The grants we put in place, so once we started putting the center in place, we met, we had workshops, we have been hit by COVID, so we moved online. We had a lot of seminars, we met, and then once we came to critical point of discussion where we felt, oh, now we have enough knowledge of what the others are working on, we initiated a campus-wide call for collaborative projects where we in principle fund postdoc salaries for 1 to 2 years in order to kickstart, to seed new research streams at EPFL. Next slide, I will show you some examples. The first project we selected competitively is titled AI for Healthcare. It's about creating a digital digital twin of the heart with the idea to better detect, to better follow patient treatment. This is a project which is set up between 2 labs, one in basic science in math and the other one in engineering signal processing. The second one, which we'll hear more about by Dr. Bolotnikova is entitled Intelligent Assistive Robotics. So I won't spend more time about that. Maybe just, it's, I think, a total of 14 labs that engaged to actually in this project and to work together. The third one is entitled Decentralized Edge AI Infrastructure with Applications in Health and Human Exposome. This is a project where we have people from engineering and informatics and computer science coming together, working together. And the fourth one is entitled Digital Twin for Real-Time Monitoring and Anomaly Detection of Complex Systems, where we have someone from math and someone from engineering coming together and working on the project. Maybe just to conclude my brief introduction to the center, we are also organizing events in selected topics which are related to our activities. I would like to mention the CIS Digital Twin Days, which are upcoming on 15th and 16th November 2021. The event will take place in a hybrid format, which means we will meet on site in Switzerland, but you can follow also all presentations online. The event is going to be streamed. You see a small QR code here. Just point your phone there and you'll get the link to get all information about our speakers, the institutions, and the topics that are going to be presented. Thank you for your attention. I'm happy to pass over now to Dr. Bolotnikova for the presentation of the CS Collaboration Grant 2 in Assistive Robotics. Thank you.
Thanks, Ian. Please, Anastasia, the floor is yours.
Thank you for the presentation, and Jan, thank you for already touching a bit upon the project that I will talk about in more details. So my name is Anastasia Bolotnikova. I'm very happy to present today in the Swiss Korean Science Club more details about the CIS Assistive Robotics Collaborative Initiative. So this is the project under the CIS that is aiming at developing intelligent assistive environment for people with special needs, for example, disabled people, elderly. So the focus of research in this project is really about the modular and distributed assistive robotics system, development of such, and then addressing the scientific challenges that come along with the development of such system and application of them in the assistive context. So grant vision is to create the network of assistive devices at the intersection of smart homes, neuroprosthetics, and rehabilitation robotics, with such devices as multifunctional, mobile, and reconfigurable furniture, robotics arm for fetching objects, and various robotic devices for assisting transitions and mobility. And we also aim in this project to interface the devices that we will develop with existing assistive technologies such as wheelchair, exoskeleton, and existing neuroprosthetic devices. The collaboration framework, as Jan has already mentioned, is really there to enforce people from different laboratories coming together and bringing the expertise from all of those different research units together from the fields of robotics, human-robot interaction, machine learning, machine vision, neuroprosthetics, distributed and edge AI, and smart home, because all of those expertise are key components for addressing the challenges that will lead to creation of intelligent assistive environment. We also have the educational impact in this collaborative framework, as different labs come together not only to do research between postdoctoral and PhD researchers, but also to co-supervise master student projects, which leads really to more diverse types of projects that are multidisciplinary, as the experts from field of robotics, for example, collaborate with machine vision experts to guide the master students to address additional challenges that are all related to the CIS Intelligent Assistive Robotics project. And also within the collaborative framework, we are aiming at sharing resources such as testing facilities and in collaboration apply for the project's grant to make this project bigger and make it grow over the years. Some examples of the partners involved in this really big collaborative initiative First, I would say that it is primarily led by the Biorobotics Laboratory and Reconfigurable Robotics Laboratory, which I'm associated to both of those research units. But also this project involves Visual Intelligence for Transportation Laboratory, a Learning and Algorithm System Laboratory, Assistive research group here at EPFL, such even startups as Care, who are developing the hand exoskeleton, and NeuroRestore, working on the spinal cord stimulation technologies for enabling people who have lost the ability to control some muscle to restore this ability. And quite several more. In total, we have 18 research units involved in this collaboration. So it's a bit too time consuming to present all of them, but those are the partners that are most actively involved in the collaboration at this point. So what we will focus on as a research in this project. We would like to really explore the opportunity that seems to be underexplored of the use of modular and self-reconfigurable robots for human assistance. So modular robots are great because unlike the fixed shaped robots, they can be assembled into any type of structures to perform any type of tasks. And in the context of human assistance, what is important to know is that all people are different, and people with disabilities also have different needs in terms of assistance for the daily life. So we would really like to explore how such type of technology that can assemble into different structure by itself can address this challenge of adapting to the user-specific needs. So we have already shown in the lab, this is the robotic platform developed in Biorobotics Laboratory, that they can those robots can be commanded to assemble to different kind of structures. They can also be used for locomotion, for fetching objects, and also manipulating objects. As you can see here, the object being passed from one robotic arm to another. So we would really like to explore more of how, what are the assistive use cases that those robots can address efficiently and intelligently in this project. We would also focus on this in this project on the use of modular origami robots. So the concept here is the same. You have different individual components that are modular robots. When they are assembled together, they can create different shapes to address different tasks. So the idea is to find what is the application use case that could be useful in daily assistance for people with disabilities. In this project, we will also focus on the use of soft pneumatically actuated robotics that are inherently compliant to create a safe human-robot interaction. So this is the example of a robot developed at Reconfigurable Robotics Laboratory that by controlling the pressure, the air pressure that is being used to control the robot can either morph its shape or completely compress. So it results in a lightweight robotic structure that is can be very compact, which is very important because many people, for example, people on the wheelchair who would like to have a robotic arm assisting them, they explicitly say that they don't want this arm to be big and bulky and heavy. So with such technology, this this kind of robotic arm can be lightweight and compact, so that when it's operating, it can stretch out to reach, for example, some object lying on the ground, and then when it's not in use, it can compress and hide away. So those, again, it's type of modular robots, so those modules can be assembled together into an arm, and the vision is to use it as almost like a third arm that people can use in assistance. And we would like to also explore the inflatable elements that could be used as part of the furniture in the environment to help with the transfers, for example, for elderly people who need just a bit more help when they are performing a transfer, for example, sit to stand. And one of the projects that we are tackling now is on the use of mobile assistive furniture. So the grand vision is to have furniture that is typically static in the room become mobile to assist with various tasks for the human. And to enable this to become a reality, we are focusing on some individual blocks that are being addressed by different students working currently under the co-supervision of different laboratories at EPFL. So we have a student working on furniture localization supervised by Vita and Biorop, human localization in the context of assistance, ensuring the inclusiveness, and the 6D localization of the human. Then we have a master thesis student working on the swarm behavior of the furniture to create this intelligent furniture choreography that will make sense for the human in the environment. And we have a student developing the mobile furniture platform that is co-supervised by Biorop and our laboratories. So the application use cases for this mobile assistive furniture, they can be such as getting out of the way to help the person pass through the room. For example, a person coming in a wheelchair, instead of avoiding the obstacles that are the furniture would just intuitively get out of the way to let the person take the shortest path from where they are to where they want to go in the room. Or also coming towards the person and bringing items, for example, instead of a person going towards the chair, towards the table to get something lying on the table can cooperate with the person and come towards them. And also we envision the use of such mobile assistive furniture to follow the pilot in an exoskeleton to allow to rest at any point in time. And also it can be used in such cases as accompanying a Parkinson's disease patient for support and reassurance. And the future work within this project will include such aspects as interaction of the mobile furniture developed in the first year of the project with actuated exoskeleton, integration of the developed devices with existing smart home elements and existing infrastructures, and integration of distributed and wearable sensors to monitor the pilot status, to use this as a feedback to pass to the assistive devices for them to adapt to this state of the pilot at any point in time. And integration of all these elements in the assistive compartment. And eventually we would like really to test the developed technology with the spinal cord injured patients in the assistive compartment. So at this point, I would say thank you for your kind attention. Here on the screen, you have a QR code that you can also use to read a bit more about the project and see what are the contacts you can use to get in touch with us if you'd like to know even more details about the project. So thank you for your attention, and I would be very happy to answer any questions that you have.
Thanks a lot, Anastasia. Now is the turn of Professor Kyung Hwan-jin. Please, Kyung, share your screen.
Yeah, kind introduction. And yeah, thank you for the previous speakers for the very impressive result. And yeah, this is my turn. I'm a little bit concerned about my direction of presentation. I only preparing my presentation on some focusing on introduction of our department, especially for this, only for our department. So it will be not many informative in the sense that we only talking about the ICE department. So yeah, let's assume that the first, and our department name is Information and Communication Engineering. So first of all, today I will going to introduce only one center, research center about collaborative center for AI. The other one is the issue of the time of being. So I will only introduce AI center in our department. And in our department, actually we. First of all, I want to give you some introduction of our affiliation, the DGIST. We are located in the South Korea. Is maybe for your information, it's a 3-hour distance from Seoul, capital city, and by car. And it is kind of pretty much lucky to have in only 1 or 2 hour distance we can meet the ocean side. So it is little bit different from Swiss. We have some little location, and not for distance. We can go to the beach and we can eat the seafood from there. And so a lot of very chilling places, around our territory. And especially we are located at city, the name as Daegu, which is located at here, as you can see. So in DGIST, we are total like 3 department is there, and one of our department is aim to develop some interdisciplinary research, especially on the information technology. Moreover, we also would like to exploit more AI-related one, including machine learning, recent state-of-the-art machine learning technique, and also some material, new novel material devices, and something related with the circuit and devices, and so on. So we are focusing on that too in our department, and mostly it can be categorized as these symbols and ISABC. Each part, our faculty, dedicated faculty, will researching on each topics, especially such as this intelligent computer systems. We are researching on computer architecture and operating system, as for example. In connected smart system, many of our faculties are working on the mobile communication and Internet of Things and wireless sensor networks. And in the other branch, advanced semiconductor, they try to make the next generation transistor and also neural interface. And also HCI is also very highly got highly intense attention from the outside. So many professors are working on that. And biomedical system is developed by several groups, such as smart healthcare and bioinformatics, and brain-machine interface also one of the branch of in this stream. And the cyber physical system, which is relevant with the digital twin things, and they try to working on the simulate a very virtual system which is as close as possible to the real system, and they also want to exploit more resilient control system from that. And also they can do some simulated self-driving car and autonomous driving system from this virtual environment. So as you can see, all the kinds of branch we working on is quite very attached to the artificial intelligence technique. So we also, many of faculties already try to bring some very state-of-the-art techniques into their own field. And also even more that, they try to make some new novel system which combines some interdisciplinary way, combines together and try to observe new things from them. So our faculty members list is as follows. So we are in total 28 professors is affiliated, and also we have global research networking, as you see here. Yeah, so we in total in this size we collaborate and research between us, and we are very highly motivated students, also researching on their own topics, and we are kind of very active to hold some conference, student conference, which communicate each other and try to communicate and transfer their knowledge to the other domain. And also we have a lot of events such as happy hour inside campus. So then I would like to introduce some components of our subdivision of our department. We have four main centers in our department. First one is the CCAI, is a collaborative center for AI, and second one is the Extreme Research Center for Extreme Exploitation of dark data, which is really relevant with data science system. They try to overlook about some dark data set, and they try to reuse some very uncovered databases. So actually, I don't know any details about this center, but they are kind of try too hard on researching about the database and sort of things. And the third center is Brain Engineering Convergence Research Center. I think they are focusing on brain-neural interfaces systems. And the last one is Resilient Cyber Physical Systems Research Center. And as I said, this is more, you can just guess this one as more like the digital twin simulators. And they try to understand the real world through the cyber environment. And from now on, we are introduce you about Collaborative Center for AI. Actually, in our department, these members of faculty are dedicated on the AI system more recently, and they try to focus more on developing some new system based on AI. And we are, for simplicity, we are categorize them as AIoT and Next AI and Wellness AI and Systems AI. And our this center chair is Professor Kyung-Jun Park. He is major and his research field is learning-enabled CCAS systems. And also the other two members are also joining recently, and they are also going to be researching on HCI and embedded software and software engineering, etc. And so I labeled on below their name, I labeled on their each homepage, so you can visit their each page if you have some interest. So also we summarize each research field and so on, so you can check their name and see what they're doing. But I'm going to briefly introduce you about the main theme at each branch. First one is AIoT, and second one is Wellness AI, and third, Next AI, and last one is System AI. And this first application area, AIoT, this faculty 3 members is majorly working on this research, and they are trying to develop federated learning especially for IoT. So in the network system, there are many kinds of demands for some sharing, some efficient network throughput, or other some distributing some bandwidth efficiently. For that, they need to learn some each circumstances, and each source location need to be fair to share their resources. So which should be in balance, very well balanced. So for that matter, nowadays many researchers try to use federated learning to balance this whole networking system. And also this combined with associated with this autonomous vehicle also can be one of the title of this AIoT systems, because they are trying to allocate their task on the cloud servers, and this cloud server can operate some communication system with the end user. through the network. And this one of the hard application for this end user is smart vehicles. So on the basic of this communication system, they can do some communicate through the network system, and they get some instruction from the cloud server, which is based on their transmitted bit stream information, such as some camera information or some location information. And the last thing about this IoT, AIoT thing is the CPS equipment. They like to monitor and control CPS system in very safe way. So they also very care about the security problems. So they try to unblock the hackers and black hackers, and this secret thing is also included in this domain. And all this one can be enabled with AI approach. So this branch try to exploit AI within this specific applications. And the second one is the systems AI. And as far as I know, this group is try to model the chip hardware accelerator, and more hardware-friendly neuromorphic devices, or basically chip-based one. So they design circuit blueprint, and they try to allocate efficient bus speed or bus things, and on top of that, they want to learning some pre-trained model from the neural network. And then after all, they want to deploying their pre-trained model on their own developed chip, which is quite a hot topics for many, including many very major vendors, semiconductors vendor, also as well as just electronic vendors. So they try to find some efficient mobile hardware and also efficient hardware for AI systems. So they are actually taping out the real system chips in their lab. And third part is AI combined with the healthcare. So we already have some connection with our local administration and local branch of hospital and other affiliations. We can get some medical information from them, and for that matter, it is also very important to not sharing policy about this medical information. So we need to use their own local data set on the local places. We only share this weight information from neural networks, such as some gradient from the neural network, and using kind of federated learning, we try to learn some universal neural network based on this federated learning from each local servers. So and so for that one, we also need the data pre-processing and some analysis and engine for diagnosis. So this all relevant technique is already developed by several groups in our department, and they also try to launch some techniques through some startup and other way. Yeah, and the last one is so based on the bio-inspired some components such as neural structure and neural spiking communication way of actual neurons. There is some group to get some inspiration from that phenomena and try to make the next generation neural network scheme or hyperdimensional scheme through that some observation. So this is more advanced one, and this is a very future work, and they try to learn this actual neuron and actual this mechanism from human phenomena or something like that. Yeah. So these all four branches are very significantly worked by our this branch group, but at the same time they collaborate very well between them. So it is not limited to this specific four area. So for more detailed information, you can visit their own page. But unfortunately, we don't have such as a main homepage for CCAI. So if you need more contact and you think you need more information for general for CCAI, you can just visit me. You can just contact me for that matters. And yeah, that's all about my slide. And this is our campus landscape. Okay, thanks for your attention.
Thanks a lot, Pyong, for your presentation. And no worries, actually, the scope of today's Science Club was really introducing about the centers, and it's also great that we could have an applied example from Anastasia about one of the projects ongoing in Switzerland. Now is time for a discussion. So I would like to invite the listeners to ask some questions in the Q&A section there in Zoom. But in the meantime, waiting for other questions, I will start on my side. And as I said, I mean, I was really impressed by the two presentations about the two centers, and then obviously on the applied part. I would like to start with Jan and ask also some more practical questions. For instance, how could students and researchers who are interested in an exchange or collaboration get in touch with the CIS?
Thank you very much for the question, Alessandra. I think the best way to get an idea of what the center is currently working on is to follow us on our social media. We tend after Twitter, LinkedIn, and Instagram accounts of CIS. Another way to get in touch might be to follow our public CIS colloquia, which you can find on our website. And of course, last but not least, you might join online for our CIS Digital Twin Days, the 15th and 16th of November. If you have any questions or specific questions, you might also just simply write us an email at cis_contact@groups.epfl.ch. I just put this in the chat right away, and we will get back to you within a couple of business days.
Thanks a lot, Jan. Now I have a question for Anastasia, because we talked so far about the center. I mean, the great idea of the convergence between different technologies, etc. But I can imagine that this collaborative approach is also quite challenging. So I was wondering, what are the biggest challenges to be addressed within the CIS Intelligent Assistive Robotics project? So how if there were, and which kind of challenges they were, and how you deal with them?
Thank you very much for the question. So on the side of management, it is a big project. As I mentioned, we have 18 different research units involved. So yes, one of the challenges is just to keep track of all the expertise that we have access to make sure that we exploit them as efficiently as we can. Because in the collaborative project, in a big collaborative project with many partners like this involved, it becomes a bit hard to keep track of just how much of different types of expertise we can mix and match in different projects to achieve some diverse and interesting results that have not been achieved before. And just on the side of intelligent assistive robotics, I think one of the biggest challenges is just creating the control algorithms for the robotic platforms that are intended to assist humans, to collaborate with humans. So we need to aim for this intelligent behavior that is intuitive, predictable, and useful for the assistance to the human with special needs.
Thanks a lot. I think that these challenges can be also kind of extended to many of the projects, I mean, which belong to the center. And I have a question now for Professor Juan. Ian, for instance, talk about which kind of support researchers receive from the center and how, you know, also the opportunities are kind of gathered from the different departments of the universities. So I was wondering, what are some supports from the Department of ICE at DGIST to the activities of the researchers, and if there is any difference between local and international research, what must be taken into account?
So first of all, the support from our school is, I'm not sure about from the outside student. I'm not sure there is any kinds of support for that. But at least from the DGIST side, we are supporting there some stipend and this travel fee for some short-term interns to the outreach affiliation, such as, so we are gathering some application from our department student, graduate student, and then we select them and we send them to any outside university, such as Epfl or ETH or other site. So we have some program inside our department, as well as I believe that there is also other types of support from our university for the international student. But I hope I know that right now, but I have no information for that right now. So yeah, so there is such supporting information for that. And what are the second question from you? Does local and international?
No, yeah, I was wondering because just talking about the researchers, if there is if there are specific funding opportunities for international research between DGIST and other organizations in these specific fields.
So as far as I know, there is some internal project support that if we find some counter, yeah, if we have some partner from the outside, then I believe that we can make some own project from which is supported by our university, not from our department, but it has to be reviewed by some reviewers, and then yeah, I hope to be, yeah, there are existing some several programs like that. So I believe they also have some opportunity to collaborate with the outside university, even which not is limited to the international affiliations.
Thanks a lot. Before asking a question that we just received from the audience, I had a question for Jan, which actually is connected to what I just asked to Professor Juan. And is CIS also part of international research networks? I would like to ask if there are already relations established. sorry, with organizations in Korea or not, or if you are planning something. And then I will ask the question from our audience.
Thank you, Alessandra. Yes, that's a very good question. So we strive, of course, to be well connected. We are part of the Eurotech University Alliance here in Europe, which are 6 technical universities comprising EPFL, where we are part of different focus areas also within AI and others, which allows us to connect on a European level. Actually, thanks to the Science and Technology Office in Korea, we already started reaching out to institutions in Korea to see whether we can find opportunities for the collaborations. And I hope that, well, that we can base ourselves on our last meetings to move these reflections further.
Thanks a lot. So there is a question from Frederick, and the question is addressed to both Professor Juan and Jan. So what do you both think about collaborative research centers between universities and large tech companies? Are there any collaborations currently? Are these collaboration wanted, or is better to stay independent for a university in that regard? Who wants to start? It's same.
Maybe I can start.
Yeah.
Yeah. So thanks for the question. And as far as I know, we have some this company partner inside our homeland, like the SKT and very big company. Also, we have some agreement with MOU for interchanging more front information between them, and we are not limited to to separate from this big tech company. We also try to reach out many other companies for connecting our students to their program, such as internship, or we try to provide some good opportunity about this such internship to our students as well. And we also hope that we also share our knowledge to this company domain as well. So that's what we want, and we're actually doing that in our domestic company inside. So we are actually connected to 1 or 2 big tech in Korea right now. And I think it is positive to our university. Yeah.
Thanks. Jan, to you.
Thank you. I think, well, how to say this? We have a long history, I think, at EPFL for working together with industrial partners. As I have also put on one of the slides, this is also part of one of the missions we fulfill with CIS. We are not limited to domestic collaboration partners, so we have very interesting discussions going on with national and international partners for the time being, and they're looking forward to see whether this could then at the end come maybe to research projects within the domains we're active in. As for students, we also support and promote projects that are proposed by industry. So if someone from industry is listening in, please feel free to contact us with any master or semester projects. We're happy to relay them to the respective networks within EPFL and the colleagues, professor colleagues then involved.
Thanks a lot. I have a question for Anastasia. We know these projects, I mean, in general, it's scientific research, but even more when it comes to convergence of many disciplines, they have big long-term goals. But I mean, long-term goals are achieved thanks to a series of short-term objectives. So what's next? What are the short-term objectives in your project?
So thank you again for a very nice question. Some short-term objectives that we are looking forward to is, so I presented how we decouple this mobile assistive furniture into different subparts that individual students can address within a frame of a semester project. Then the next step after that would be bringing all of those pieces together like puzzle pieces to bring the final demo that exploits all those individual technological bricks to bring this into reality, to actually have tests with the human interacting with the set of mobile assistive furniture.
Thanks a lot. As all of you actually mentioned the students, the involvement of students in master projects, internships, and activities which may happen, I mean, inside the centers, but also connected to companies and private sector. I was wondering, and this is a question I have for Kyung, what makes the collaborative Center for AI outstanding in Korea among many of the graduate school in AI which are already existing, also in other big universities? I think what makes your center more appealing also for students to come there?
Yeah. First of all, I knew I've been in Lausanne 3 years, and for the good news for students from EPFL is we are very reachable to the ocean, ocean side. And it's a quite different mood from the these mountains. So it is very good opportunity to experience of that things. And our affiliation DGIST is but they are kind of very free mood. All people is kind, and also many of our faculty is very activated compared with other big schools in other locations, especially in capital Seoul. There are also many universities there, but in our DGIST we are more activated, and our faculty members more relatively younger than the other schools. So we are active, and we are also very not hesitating to make some kind of very workshop or collaboration, and there is no limit, not much limit upon that. So I think our DGIST is kind of a brand new university compared to the others, so we have more energy than the other side, I believe.
Thanks a lot. If there are no other questions from the audience, I'd like to make some comments on my side. As I'm a bit super partes because I'm Italian, so working for Switzerland, and I lived in Switzerland many years, and then I'm now in Korea. I could experience both systems, and I must agree with all what was said so far. I think that EPFL is an excellent organization and extremely connected to the industrial sector. So many of the ongoing projects, also independently on the Convergence centers, are happening with industrial organizations. So this is, I think, really appealing also for Korean students interested to exchange and go to Switzerland. Lausanne is an attractive location because maybe there is not the ocean, but the lake is wonderful, and I think it's extremely attractive also for people interested in nature and having a kind of campus life. Same for DGIST. I was impressed. I think it was the first university I visited when I came to Korea, and it reminded me of the Swiss campuses, and it's really what Kyung just said is true. Staff is really young. The classes are in English, and there are many activities. There is a big rowing festival every year, which involves also a team from Switzerland. It's not EPFL, but the Zurich cousin of EPFL, ETH. So it's really interesting. On our side of for the Science and Technology Office, what we can say is that if Swiss students are interested to come to Korea, they have also the opportunity to apply for internships in some companies and private sector. So thanks to some support from the Swiss government. So in case there are any question about this, you can contact our office. And also I could identify some interesting common points between the two organizations and the two centers. And I absolutely, Jan, what you said is true. We will continue to support and trying to establish connection, and starting maybe with student exchange, students who could have the opportunity to work also on appealing projects like the one of Anastasia, and then so facilitating research connection. So you have all our support on both Swiss and Korean side. So I like now to close this science club and thank the speakers and for their participation. And also I like to thank the people who join us live today. With all the rest, we will share the recording of this webinar. And you can always contact us and follow on our LinkedIn, because it's there that we share most of our activities and events. I like to ask the speakers to put their camera on for a moment. We just take a screenshot, which is the new peak, the memory peak for this kind of events. So just smile, please. Done? Okay, that's done. So thanks again, and I hope to meet you in person very soon. Have a good day and evening.